Yo, round 3. Here we go. So lesson 1, we looked at just some data, right? Kind of talked about taking notes. Lesson 2, we looked at how to read a histogram. And now here in lesson 3, which I think I called 2B or some nonsense in the last video, but lesson 3, we're going to learn how to make a histogram. So again, some of us maybe have some exposure to this in geometry. Maybe it's new to you, right? Doesn't matter either way. Let's do it. Let's jump right in. So lesson 3, creating histograms. Definitely got one of these in our summer assignment. Let's do it. So here's some data. So data below shows us the total numbers of medals won by a sample of 26 countries in the 2016 Summer Olympics in Rio. Right, 2021's they're not happening yet. So those are our most current Summer Olympic data. So we've got, right, 26 numbers here, a set of quantitative data, right? The quantitative variable we're measuring is number of medals won. The countries are relevant for the sake of the histogram. I just thought you might be curious. But the data, we really only care about the numbers, right? So we have one quantitative variable, number of medals won, and we want to now create a histogram for this data. So before we start to do that, let's kind of go through, right? Grab our notebooks here and jot down some of the kind of the fundamentals for how these are created, some of which were touched on in the last video. So your title there, lesson, or like whatever, lesson 3, creating histograms. Excuse me. So a histogram shows us how data values are distributed across values. We call that the distribution, right? So a histogram does not allow us to reproduce the exact original data set always. Sometimes it does, we'll talk about that. But it does show us, right, what intervals data values fall in. It shows us what data values, right, a set can take on, right? What could the credit card debts have been in our last video, or here, what amounts of medals, right, could be possible, right? We can determine that from looking at the graph. We can see where there's gaps. We can see where there's clusters, right? In the last video we saw, there weren't that many college students towards the end there above $550 of credit card debt, right? But there were big chunks towards the lower end. And then we can see specifically how many data values are in a certain interval, right? And we wrote that sentence interpreting that, I think, 21 in our last video. So when we look at a histogram, we're looking at the distribution of the data, literally how it's distributed. Where are the values, right? Where are they clustered? What could they take on, and so on. When we create a histogram, the x-axis, right, the horizontal axis there, that's always the variable being measured. I don't really like that I said response variable here, whoops. Right, so the x-axis, that's our one variable, the variable being measured. I'm gonna cross this out because I don't really like it that much. And then our y-axis is always gonna be the frequency or count, right? So the y-axis is like how many things, how many data values were a given interval. Right, so like this tells us there was, the y-axis tells us there was one data value between negative 0.5 and 0. Like sure, some data values can be negative, temperatures and stuff, right? There were 3 data values between 0.5 and 1, right? So this, which we call the frequency or the count, that's the number of data values in the interval. And that's not a variable, right? That's not something we're measuring. The only thing we're measuring is along our horizontal axis. Another thing to keep in mind is when we create a histogram, we don't space out the bins, the bars, right? We call them bins, right? Whatever, the bars. The only way you would see a space is if there was a frequency of 0. So when I look at this, right, when I say a frequency of 0, when I look at this and see a space, it's not that there was anything, it's not that anything was spaced out. It's just I can now tell, right, there were no data values between 1 and 1.5. So a bar graph, the categories are spaced. So when we create a bar graph, we should space out those bins, those bars. But in a histogram, we do not do that. A space implies a 0. And then as we touched on in the last video, if a data value falls on the end of an interval, it always goes in the bin to the right. And that was discussed with the range, right? So a 0, if there's a data value of 0, that goes in this bin from 0 to 0.5. Or if there's a data value of 1.5, right, it goes in this bin to the right, always, right? So there cannot be any 2s in this histogram, because if there were a 2, that would go in the bin to the right. Okay. All right, just kind of touching on these. Let's see what else we got. I mentioned that, so last little kind of generic info before we create a graph. So I mentioned that in the histograms we've looked at so far, we cannot really reproduce the original data set. So if the bins fall between 2 values, meaning here, right, and this histogram should look familiar, the bins are, you know, set up, this bin is between 100 and 150. Or this bin here, right, is between 200 and 250. So, and the bold is there because that's really like what you want to write in your notes, right? You don't need to write every word. Bins fall between two values, right? That shows the frequency within that interval. And if you want, you can even add, right, we can't reproduce the exact data. And by that, I mean, as I said in the last video, we know there's like 23 students with credit card debts from $100 to $150, but I don't know the exact amounts of debt for those 23 students. Now, sometimes, right, if I were creating a histogram of like AP exam scores, like there's only 1, 2, 3, 4, 5, so I don't need to look at between two numbers. And so one thing we need to know when we create or read a histogram, if the bins are centered, right, if the bins are centered, then that means each value in that bin is equal, each data value in that bin is equal, right, to what's on the x-axis. So here, the fact that this bin, right, goes up to a height of 3, it's not there were 3 numbers between anything else, right? See how this is centered around the 33.5? All 3 of these data values are exactly 3.5. So whether we center the bin or put it between two numbers, right, that makes a big difference in how we read and create the histogram. So, right, like over here, right, I know there are 2 data values, and I know both of these data values are exactly 36.5 because that bin is centered, okay? So in this gray scenario at the bottom, I could reproduce the original data set, right? I know the first number would be 33, then I know there's 3 33.5s, and so on and so forth. And then all that stuff in the last video about estimating range and median, right? We wouldn't have to do that because we'd have the raw data. We could just find the exact range and the exact median. So let's make a histogram. So here's our data set, which I showed you before, which was like, why'd I even show it to you before? Anyways, here's that same data set. We're going to create a histogram. We've got 26 data values, or based on what we saw in some in our last video, right? So our N, our sample size is 26. And again, the countries are irrelevant. So we can see that over here, the minimum is 1. Why, you know, Puerto Rico is its own country in the Olympics. Kind of weird, right? And then, right, yeah, whatever. That conversation for another day. And then the US, the max at 121. Okay. So I'm actually going to jump over to the whiteboard. Let's whip this thing up. So at the top here, those are just the 26 numbers of metals, right? They don't look exactly like they did on the screen. If you're putting this in your notebook, maybe, right, you do the same thing I'm doing here, right? And these are, right, you can label, these are the number of metals 1, 2016 Rio. And the question, the task here is to create a histogram. So step 1 for me, right, is maybe if you're a step-by-step person, maybe this helps. The first thing I'm going to do anytime I create a histogram is I'm going to set up my axes. The x-axis is always the variable being measured, which in this case, it's always a quantitative variable for a histogram, right? That's the number of metals 1. And this y-axis over here is always, we can label it as the frequency, we can label it as the count, or it's the number of data values that are in each interval. Right? In the last video, this represented the number of college students that had each credit card debt. In context, here, this is going to be the number of countries. How many countries won between whatever and whatever metals. So I say whatever and whatever. Now we got to think about how to label our axes. Now we want to get to the point where ultimately we're going to create this graph on our calculator, and that's what, right after this, that's the last piece of this video. But I always like to set up the axes by hand myself first, because when we have to set the window up, typically if there's a part that students struggle with, it's that window. The window is really just translating this information to your calculator, and we'll see that in a bit. So as we think about this, the numbers of metals 1, right? The smallest number was 1, and the biggest number was 121, right? So we need, like, we can start at 0, right? So I'm just going to start at 0. On a little side note, if you don't have to start at 0, like in your summer assignment, I think the smallest number is maybe 550. whatever, something like that. If you're going to start at 500, that's fine, but we just show a little break. So we use this little squiggle here to show a break, and then I can start at 500. We would not want to start at 500, like right on the y-axis, right? Because that represents an x value of 0. So kind of a poor example for me to use in that sense, that we don't get to see the break, and that does happen on your summer assignment. But hey, summer assignment's practice, right? That's what we'll figure out. So I need to get from 0 to like 120, right? I have to go past 120. So like, I'm not going to count by 2s. I'm not trying to do that. Roughly, like, you don't want to have 100 little bins. I don't want to count by 1s. That's not going to be very helpful. But there's not a right answer as to what to count by. Like, even if I count by 10s, then I'm going to have 12 potential bins. So maybe I'll count by, I don't know, in class people will be shouting out 20s or 15s or whatever. Like, there's not a right answer here. Let's count by, I'm feeling crazy. Let's count by, I'm trying to make sure something happens. Yeah, you know what? We're going to do it. We're going to get crazy. We're going to count by 10s. So we're going to have 0 to 10, 20, 30, 40, 50, 60, 70, 80. Nope, we're not going to count by 10s. And you know what? I could do this whole video over and not make that mistake, but that's not real life. Like, that might not work. Oh, I ran out of space. 10s was a bad idea. No big deal. No big deal, man. Let's count by 20s. 20, 40, 60, 80, 100, 120, 140, 160. Notice I'm not labeling this as an interval, right? Don't be giving me any of that nonsense. We have to label these values exactly. Just rewriting those so that you can actually maybe read them. So now, as we go to create the histogram, what the histogram is showing us, right, we want to show the height, how many countries had 0 to 20 medals. As we think about labeling the y-axis, right, there was 26 countries, so there's no way this can go higher than 26, but right, they're not all going to be in one bin. So like, I don't know, on the y-axis, you can pretty typically, in class, I'm not going to give you 500 numbers to make a histogram of, maybe 20, 25, so you usually can pretty safely count by 1s or 2s. I don't even know. I don't know how high we're going to have to go. That's part of the deal, right? It's a little bit of trial and error, but I'll count by 1s. We'll see what happens. So now, as we create the histogram, we want to think about how many data values, how many countries are in each interval. So the first, how many countries had 0 to 20 medals won? But keeping in mind, this isn't going to happen right now, which is kind of poor design on my part. If there were a 20, it would go in the bin to the right. So my first bin, let's see, I'll do these in green. So how many countries had 0 to 20 medals? So we jump back to the top here, 0 to 20. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 countries had 0 to 20 medals. So my first bin up here is going to go all the way up, right? 15, I don't know, probably up here somewhere. Right, my first bin goes up to 15. You're like, oh my God, it didn't even go high enough on the y-axis. One thing that I like to do when I create my histogram is I like to label top the height. That way, if I'm off a little bit, it's kind of like an insurance policy. So this bin's going up to 15. And I ran out of room. Next up, right, we're looking now, how many countries won between 20 and 40 medals? I'll do that one in purple. So up top here, 20 to 40. 1, 2, 3. So 3 countries won 20 to 40 medals. So this bin is only going to go up to 3. And then next up, how many countries won 40 to 60 medals? So we're going to go up here, 40 to 60 medals. I'll go back to my green. So we've got 1, 2, 3, 4. So this next bin is going to go up to 4. 60 to 80 metals. Oh, I didn't show that. All right, here's my next one going 4. 60 to 80 metals. Back to my purple. We've got 1, 2. So this 60 to 80, we're going to go up to 2. I only have one number left, so 80 to 100, right? That's 0. 1 to 1, 100 to 120, that's 0. 120 to 140, that's 1. That's the US there. And then 140 to 160. I don't even know why I counted that high. There was no number there. So there's our histogram. Now I can double check a little bit. There were supposed to be 26 countries, so these numbers better add up to 26. 15, 18, 22, 24, 25. Well, that's not what's supposed to happen. So what did I miss? Oh, I got this 22. This is a good example again, right? Like I could do this over, but this is an example of, right, write on stuff. Don't do this all in your head. And in a minute, we'll look at how the calculator can do this. Like this mistake that's happening right now would never happen if I use my calculator. So this 22 here, so there were actually, because of this 22, this bin should actually go up to 4. But that also shows, right, kind of the power of checking your work. I would not have recognized that mistake if I didn't double check to make sure that these added to 26 countries. So 15, 19, 23, 25, 26. So now I'm good. And so there's a picture of our histogram. We always want to make sure we label our graph. We have to label the axes, which I've rubbed off with my hand, right? We could label it as frequency or count. That would be full credit. In context, that's the number of countries. We want to label our x-axis, and then we want to give a title. So I'll just call this Rio 2016. I'm not grading the quality of your title. Don't spend too much brain power. Although it is fun when students write witty titles. So that's how we create a histogram. The one thing that didn't come up in this video, I guess 2 things. One, if we had a number like 80, that would go in the bin from 80 to 100, right? Goes in the bin to the right. 2, if we had exact, like if we were looking at AP scores, we would end up centering these bins, and that's something we'll have come up, right, at some point. All right, so that's how to do this by hand, right? You can do the summer assignment question now, but we don't really want it to take that long to do a histogram, so we also want to be able to create this in our graphing calculator. And so it might be a good idea to just pause the video and write down these steps in your calculator. So now this only applies if you're using the TI. All right, so if you're using the TI 83, 84 or whatever, that's these steps. If you bought a Casio calculator, which is a great calculator, the Casio graphing calculator, it's like 50 bucks. I don't have one with me, and so I don't have that for the video. But if you come see me in office hours, I know how to do all that stuff on the Casio as well, right? So I can show you that. I should get one of those, right? So I can present that as well. But so if you have the TI, right, here's how we do this. So as you can see, step 1 up here, right? The first thing I said I would do, right, is I would label my axes, right, in words and numbers and title my graph, right? Because that's the window. So I would do that on paper first. Right, jot those down and we'll kind of go through all this. So to finish up here, finish this video, we want to create this exact same histogram using our graphing calculator. I'm going to turn my calculator on. So the first thing we need to do is we need to enter the data. So to enter the data, you're going to press the stat button. We'll worry about a bunch of other stuff coming up, but for now, we're going to enter our, right, we're gonna have to create the list, right? So this is something we're gonna do anytime we have to put data in our calculator. So we're gonna stat and just hit enter on edit. So we want to edit a list. So you'll see all these L's coming up. That stands for list 1, 2, 3, 4, 5, 6. It doesn't matter which one that you use, right? But we want to enter this data. So you can enter each of the data values, which might require you to scroll, go back in the video, but you can enter each of those numbers, right, in one of these lists. It doesn't matter which one. When you're entering stuff, if you use the delete button, that's just going to delete an individual entry. To clear everything at once, if you have a bunch of stuff in there, you can highlight the top, press clear, and then enter. Now, if you highlight the top and you press delete, for instance, if I highlight L2 and press delete, it's literally going to delete that entire list, and you're like, oh my God, my L2 is gone. You're going to panic. Not a big deal. I just go up to where the titles of the lists are. Right above delete, it says INS, that's insert. So if I press second delete, I can insert a list. And then if you look above 1, 2, 3, 4, 5, 6, that's where it says L1, L2, L3, and so on. So if I hit second 2, that will name this list L2, right? And now it's back. So I've entered all my data in L4, right? Most of the time you're going to use L1. I don't know why I used L4, right? I was feeling crazy. So step 1, enter the data. Double check, make sure you don't have any typos. So if you're when we're gonna use our calculator, you always double check, because if you have a typo, everything's gonna be wrong. And then I also like to highlight the last number here, right? So I can see, right, see that little 26, that's telling me, this 15 right here, that's the 26th number. So I know I've entered 26 data values, right? And then that's the 27 that's blank, because I wanna make sure I had all 26. So that's step 1, enter the data. Step 2, we gotta turn on a histogram, right, and get ready. Now, one thing I'll do right off the bat, press Y equals. If you got a bunch of stuff in here, right, you might end up with some issues, right? And a lot of us take different math classes. So if you're graphing some linear function, like, you don't have to clear this out. See how the equal sign is shaded in? If you go to the equal sign and press enter, now it's not shaded anymore. Shaded in, I just made that up. Now it's not shaded anymore. That means that's turned off. So if you're taking 2 math classes, right, you're balancing your stats and other stuff, you're gonna wanna turn off your functions from pre-calc or algebra 2 or whatever while we're doing our stat stuff. So anyways, above Y equals, it says stat plot. So we go to Y equals to graph functions. We're going to go to our statistical plots for histograms and box plots. So I'm going to press second Y equals to go to my stat plots. I want to turn one of them on. It doesn't matter which one, plot 1, 2, 3, whatever. I'll pick plot 1. When we go to plot 1, we want to turn it on. So I'm going to hit enter on. We've got some options. Yours might be in 2 rows, not a big deal, but we want to create the histogram, which is this one that looks like a bar graph. In this class, we'll maybe use a scatter plot, histogram there, and then the box plot with outliers. If yours go into a second row, right, like if these 2 box plots and this thing, normal probability plot, those are in the second row, like, you can't hit down. You got to just keep hitting to the right. But we all want to choose histogram. It's going to ask for our X list. The X list is where did you type your data. So for many of you, you probably typed it in L1, so that should say L1. But it doesn't matter which list you use. Like, I typed my data in L4, so I'm going to press second 4, so this says L4. So the X list is where did you type the data. And then the frequency, this is almost always going to be a 1. The frequency is how frequently should it use each data value. And we typed each of the 26 numbers in individually, right? So we wanted to use each of those numbers once. So we'll look at in the future, we'll see some examples where the frequency changes, but this is almost always going to be a 1. You might not have the color option, right? Who cares, whatever. Now from there, right, if I just press graph, it's going to use whatever window I was using last time, so that's not going to work. I could press zoom, and then if you scroll down, it might not pop up immediately, right? Yours might stop at 7. But if you scroll down and all of us have number 9, which is zoom stat. And if we pick that, we do see a picture of a histogram, and it looks pretty similar to the one recreated. However, when I press the trace button, so when I press trace, you see that cursor pop up. If it doesn't pop up on this histogram, hit up and down. That's how you scroll between functions. You might have something in L1 or in your Y equals or something. But notice here, it's showing me that the first bin goes from 1 to 21, which is fine. So they started at 1 and counted by 20s. And so this is going to go from 21, right, to 41 and so on. Notice it says strictly less than 41, because if there were 41 right here, that would go in the bin to the right. But anyways, that's fine. A lot of times though, when we use zoom stat, it counts by like some wacky window, like whatever, 18.67s. It counts by some crazy scale, I mean, right? So a lot of times zoom stat like doesn't really work out, because it's, right, it doesn't, no, it just uses weird numbers that no one would have raised their hand and said to me, count by 13.34. Calculator does that sometimes. So in order for us to use the exact same scaling that's on our paper, we're going to press the window button, and we're going to enter these manually. And that's why I like to create these axes first, because now I can just transfer this information. Like my X min. Well, on ours in red here, our X minimum was 0. Our X maximum was 160, but really I could have stopped at 140. So whatever, you could use 160 or 140. I'll do 160. our X scale was 20. X scale is what we're counting by. So when I'm setting the window here, right, I'm just transferring this information from these axes on my paper to my calculator. Our Y min over here in blue was 0. I didn't write it, but we started at 0. Whoops, my bad, sorry. Our Y min was 0. Our Y max originally I'd only gone up to 10, but now we know that that wasn't high enough. So now we really know the Y max has to be like 15. Maybe you don't want the bin of your histogram right at the very top of your screen. Maybe you want to see a little space above it. So maybe you go up to 16 or 20 or something. And then our Y scale, we counted by ones. I don't even know what this stuff on the bottom means. And from there, I'm not going to hit zoom stat again. That'll undo everything I just did. From there, I'm going to press graph. I clearly made a mistake, so I'm going to press window again. X scale, I made 2 instead of 20. So think about that. Like, why is that the case? How would changing the scale change the graph? I mean, the answer is kind of right there, right? But if I use a really small scale, how's that going to change the view of the histogram? If I use a really big scale, how would that change the look of the histogram? Right? Changing what we count by is going to change what we see visually. So here, my mistake was this should have been a 20. Now I press graph. We can see this is exactly what's on my paper. So if I'm personally doing this, as you get better at this, right now this might feel like, oh my God, this is a lot. Right, but as we practice this, lots and lots and lots, it's all about practice, about those painters back there. If I were doing this on the AP exam, I would not have gone through and counted all those frequencies by hand at the top, right? And I missed one, right? I missed that 22. That's not going to happen if I use my calculator. So from here, I just press the trace button, and then I can transfer all this to my paper. So I know the first bin from 0 to 20 has a height of 15. So boom, I know this first bin right here has a height of 15. Then I press to the right. My second bin from 20 to 40 I can see has a height of 4. So now I know my next bin goes up to 4. And then my next bin to the right, you can see the cursor moving, right? From 40 to 60 also has a height of 4. From 60 to 80 has a height of 2. Then we've got 0 between 80 and 100, 0 from 100 to 120, and a 1 from 120 to 140. Right? And now I can quickly transfer this information from my calculator to my paper. Your goal is to get comfortable enough with your calculator, and I promise that as you get better at this, you can do it fast. Stat, edit, right? Enter that data quick. Second stat plot, turn your plot on, pick the histogram, tell it where the data is. Frequency is going to be 1. Set up a window. That's just labeling the axes on your paper. Press graph. Transfer that information. That's going to be your best bet as you get better at this. So when you're doing your summer assignment and stuff, sure, you can do it by hand, but for the sake of practice, practice with your calculator. And Casio people, right, come to office hours, and we will take a look at that together as well. All right, I think that's it. So I'll see you next video for box plot.